Welcome viewers, in this video we will see the solved problem based on the efficiency of the DC motor. Subscribe the channel for more videos and notification. Soft copy of this material available in the drive, the link is given in the description box. Now we will go to the problem. A 2-pole DC shunt motor operating from 200 voltage supply takes a full load current of 35 ampere and the no load current being 2 ampere. So, this problem based on the shunt motor. The voltage is given and no load and full load current also given. The RF, the shunt field resistance is 500 ohm, then armature resistance is 0.6 ohm. Calculate the efficiency of the motor on full load. Take the brush drop as being equal to 1.5 voltage per brush. Now we will analyze the data. What are the data available? The number of poles is given as 2 poles, P equal to 2. The voltage is 200 voltage. IL2 is nothing but load current, that is a full load current 35 ampere. IL1 is the no load voltage, no load current 2 ampere. RA equal to 0.6 ohm armature resistance. Field resistance equal to 500 ohm. The brush drop is given 1.5 voltage per brush. Totally there are 2 brushes available. So 1.5 into 2, 3 voltage. We need to find the efficiency of the motor. So efficiency, we know that the formula is output divided by input. Output power divided by input power into 100. So we need to find the input power as well as the output power. So input at load is nothing but V into IL2. So V is 200 into IL, the load, full load current is 35. So 7000 watts. The input at the loaded condition. So the input at no load is IA1 square into RA, armature resistance drop plus constant loss plus brush loss. So by adding all this, we can able to find the input at the no load, that is V into IL1. V into IL1 equal to IA1 square RA plus WC plus brush losses. Here all the values are available, only this, the loss is not available, the constant loss is not given. So we will rearrange the equation. So bring all the term in this left hand side, so that constant loss equal to V into IL1 minus IA1 square into RA minus brush drop. Brush loss is nothing but VB into IA1, voltage across the brush into IA1. So now all the values are available, so that we can easily find the loss, constant loss, right. So the voltage is 200 into IL1 is nothing but 2 ampere, no load current. Then IA is 1.6 ampere given in the problem itself, the armature current, into 0.6 ohm minus 3 into 1.6. 3, the voltage, the total brush drop is 3 and the armature current is 1.6. So this armature current is calculated separately. This armature current is not given. So IA1 equal to IL1 minus ISH. In the shunt motor, this is the basic formula. This IL1 is available, no load current 2 ampere. This ISH can be calculated as V divided by RSH, because the shunt field is connected across the load. The same voltage can be used for ISC also. The same voltage is applied across armature, field and load. So V is 200 and RSH is 500. So by simplifying this, we got 1.6 ampere. So that only substituted here, right. So by simplifying all this value, we got that the constant loss equal to 393.664 watts. The constant loss equal to the 393.664 watts. Now we will calculate the loss at the loaded condition. This is the loss due to the no load condition. So what is the loss due to this loss at the no load condition? We calculate the constant loss. This constant loss is irrespective of the load. For full load also, this value will not change. This constant loss is constant throughout the operation of the motor. right? So we can take this value for either loaded condition or no load condition. So losses at the load is nothing but IA2 into RA. Previously we have IA1 because of no load. Now it is full load plus WC plus brush loss. Now this WC is calculated in the previous no load. By using the no load current, we calculated the constant loss, right? So this value also available, this brush also loss also available, this IA2 also available, right? This IA2 is nothing but IL2 minus ISH. This ISH already we calculated, ISH already given. So based on this value, IA1 equal to IL1 minus ISH. So IA2 equal to IL2 minus ISH, right? So that is equal to 35 minus 0.4. This 200 divided by 500 is nothing but 0.4. ISH is 0.4. This value is not given directly here. ISH is nothing but V divided by RSH. 200 divided by 500, that is nothing but 0.4 into RA is 0.6 plus the constant loss what we calculated is 393.664. So we can use this value for constant loss into the brush loss. The voltage is 300 into IA2 is 34.6. From this we can calculate 35 minus 0.4 is 34.6. So by simplifying this, what we got is 1215.76 watts. The losses at the loaded condition. Losses at the no load condition, from that we calculated the constant loss that can be used for loaded condition also, because it is independent of the load. So now we calculated losses at the loaded condition. The input power is already calculated. So we need a output power. How will we calculate the output power? Output is nothing but input minus losses. Actually input equal to output plus losses, right? From input, if we subtract the losses, we will get the output power, right? So the input power already calculated is 7000 watts. The losses is 1215.76. That's now we calculated. So by subtracting we got 5784.24 watts. So this is the output power of the motor. Output power is nothing but input power. From that if you subtract the loss, you will get the output. Now we have input power as well as output power, so that we can easily calculate the efficiency. Output divided by input into 100. Output is 5784.24 watts. The input power is 7000 watts into 100. So that is equal to 82.632 percentage. The efficiency of the motor is 82.632 percentage. So in this problem we calculated the efficiency. First we calculated the input power and we calculated the loaded constant loss using the no load condition. That value can be used for loaded condition. So that we calculated the losses. So by subtracting losses from the input power, we will get the output power. So by using input and output power, we calculated the efficiency of the DC shunt motor. Subscribe this channel for more videos and notification. Soft copy of this material available in the drive. The link is given in the description box. Thank you for listening.